we're going to make some generalizations about the sum of exterior angles of all polygons. And this applet will be embedded in the next page. So for this triangle, this little blue button, as we kind of toggle that, it'll change the shape of the triangle. And the lines that are coming out from the sides, the extension of the sides, when we talk about an exterior angle, we're talking about the angle that's made between that line and the actual side. So that angle that was just highlighted red, that's an example. As we kind of pull this over, sliding this over, we'll do this. We see this blue angle is an exterior angle, and then this green angle is an exterior angle. So we know that triangles, their exterior angles have a sum of 360 degrees because those three angles made a complete circle. So let's try that on a quadrilateral. So what we're exploring is only going to be true for what we call convex quadrilaterals, not concave. And I'll show you in a moment what an example of a concave quadrilateral is. So you can explore those blue and red toggles to change the shape. And then again, as we slide this, you can see we've got a small exterior angle there, an obtuse exterior angle that almost looks like a right angle, maybe it is. And again, these four exterior angles all have a sum of 360 degrees. All right, this last one's a pentagon. So here's where we want to be careful. As we kind of play around with some of these different, we want to keep it in the picture as well, as we maybe play around with these different sliders. If this happens, where it almost looks like it gets kicked in, this is what we call a concave pentagon, and it will only be true for a convex pentagon. So we want to make sure that all of the, that if you were to connect the vertices, that there wouldn't be any vertex underneath that line on the inside of the shape. All right, so as we slide this again, we've got a really small angle there, looks like a right angle there. All right, and you'll notice that even on the pentagon, even though it has more exterior angles, what happens is that they're getting smaller, and the sum of the exterior angles of a pentagon still add up to 360. So if you're wondering why, no matter how many sides a polygon has, the sum of the exterior angles always add up to 360, well, let's look at why. So this is an equilateral or a regular triangle. All sides and angles are congruent. Oops, as I move that over, we now have a square, so a regular quadrilateral. As we move the slider over, we have a pentagon. Sorry, my page keeps like moving on me. I don't know why that is. But I'm just gonna slide this over. So let's look at what happens. Sorry, this is driving me crazy. Let's look at what happens as we increase the number of sides. All right, I'm just gonna move it there so it stops moving on me. As the number of sides increases, the shape starts to become what looks like a circle, essentially. So we know, like, when we have a triangle, it obviously doesn't look a lot like a circle, but as you keep adding sides, we get what essentially looks like a circle. And we know that the sum of all the arcs around a circle add up to 360. And so each of these exterior angles gets smaller and smaller the more that there are. And that eventually, if we were to extend the sides out to infinity, the shape would just look like a circle, which has a sum of 360 degrees.